Good morning, Algebra 2. Mr. Woe here. And as usual, are you with me? Today's video deals with section 11-3, solving radical equations. And what I'm planning on doing today, or with this video, is doing it in two parts. Now, what I want to encourage you before I continue, is I like to encourage you to take the time and go to these pages in your textbook and work them out, see what you get, and then come back to the video and watch it. Okay? So here we go. Ready to go? Solving radical equations. So let's start off with the your turn on page 560, question number 6. So we're given the square root of x plus 5. Anytime you see a power to the 1/2, that means square root. So we have the square root of x plus 5 minus 2 equals 1. And our whole goal in this section is to find the value of x, or all the values of x that will take this equation, plugging it in, doing our order of operations, finding out if the left side of the equation really equals what the value is on the right side. All right, the first rule of thumb in dealing with solving radical equations is isolating a radical. So again, I'm focusing on the left-hand side. I see we have a radical here, and then we have a constant. So the first thing you want to do is isolate the radical, so we're going to add a 2 to both sides. Then after you've done that, is you get rid of your square root by taking and squaring that side. And then since we square the left side of the equal sign, we must square the right side of the equal sign. So we're left with the next line to be x plus 5 equals 9. Then we're just left with a simple equation. Solve for x by subtracting 5 from both sides, and we get x equals 4. Now this process down here, this part down here, is just checking the solution. So again, we have to find out what x is. So I did all the work, but again, just to encourage you, try to do it mentally. So take your answer, we're thinking it's going to be x equals 4, plug it back into your equation, and see if it does, doing order of operation, that it does really equal 1. In this case, it does after you're doing your math. So we now can, with confidence, circle our answer and say the solution to this quadratic equation, or in this case, this radical equation, is x equals 4. All right, let's go to page 561, looking at your turn number 8. Okay, your turn number 8 is the cube root of x minus 5 equals x plus 1. Now, what I'm doing at the beginning of each lesson is trying to do as much work as I can to help you guys out. And as we move along into the problems, I'll leave some things out because a lot of that is just review. So the first thing we got to do is, again, we don't have to isolate a radical because we only have one radical on the left side of the equal sign. So what we're going to do is we're going to get rid of this cube root, and to get rid of a cube root, we have to cube it. And if you cube the left side, we have to cube the right side, all because of the property of equality. So that's what I did here. Cube both sides. Then the next thing you do is just go ahead and, in a sense, simplifying it or setting it up so that we can simplify it further. I know that x plus 1 cubed is the product of x plus 1 3 times. Now this part right here is the product of x plus 1 times x plus 1. Again, using FOIL to this part, I get x squared plus 2x plus 1. Then from this line to this line, we have to take this whole problem right here, this whole part right here, and do distributivity. So we're left with x cubed plus 3x squared plus 3x plus 1. Again, I'm not going over that. We've done this before, so that's something you can work out on the side. The next thing we do is we want to take our entire equation and set it to equal 0. So we're going to add an x to both sides, we're going to subtract an x from both sides and add a 5 to both sides, and we're left with x cubed plus 3x squared plus 2x plus 6. Now again, going back to this part of the problem, well, if you look at this guy right here, this is a third power, so that's a degree of 3. So that tells me that this part of this equation has at most 3 solutions. So our goal now is to find out what those 3 solutions are, and then we need to go and mentally check and see if those 3 solutions work in our quadratic equation, in this case our cubic equation. So the first thing I did is I have 4 terms here, so I can do this by factoring by grouping. So I grouped the first 2 terms, grouped the last 2 terms, and then from each group I factor out a GCF from each group. That's where I get the x squared, and that's where I got the 2. Then we go ahead and do a little bit of factoring. Again, this is going to have 2 factors. Again, if you look at it, we have a common binomial factor of x plus 3, so that we know that that's going to be one of our factors. And if we were to hide this x plus 3, what's left over will be x squared plus 2. So now we have factored the right-hand side. Okay. Next thing we do is we want to apply what is called the zero product property, setting each factor to equal 0. So I took x squared plus 2, set it to equal 0, and x plus 3 and set it to equal 0, and solve for the corresponding equations. Well, the first one, subtract a 2 from both sides, extract its root, and we get an answer in this case of x equals plus or minus 2i. The second one, very simple, just subtract a 3 from both sides, and we get x equals negative 3. Now again, previously I said this has at most 3 solutions. Well, when we're dealing with radical equations, our solutions have got to be real values or real solutions. So that right off the bat, if we go down here to our answer, our solutions, we know that x, our solution plus or minus 2i, cannot work because that is a non-real solution. So our only answer for this problem is x equals negative 3. Do a little bit of a mental check by letting x become negative 3. See if the left side does equal the right side, and this one does work. So I'll let you check mentally, but that one does work. So that is page 561 of your turn. So let's go to page 564 and work out number 4. Here we have the square root of 15x plus 10 equals 2x plus 3. Right, we don't have to isolate a radical, so we already have a radical isolated. So again, to get rid of a square root, we have to square it. So if we square the left side, we square the right side. That's what we did here. Next step is simplifying. Next thing I did was taking 2x plus 3 squared and broke it down into 2 factors. Applied the FOIL, first, outer, inner, last. And then set it to equal 0 by subtracting 15x from both sides and subtracting 10. So we're given with 4x squared minus 3x minus 1. Now this part right here is something that we are able to factor. Okay. Now again, if you don't want to use factoring, you have good old quadratic formula all set up for you. Again, b is negative 3, a is 4, and c is negative 1. You can plug that in, do your order of operations. You'll get the same answer. You'll get the same answer if you don't use factoring. All right, so I use factoring. Okay, now this one's a little bit different. We'll do this one set up. Again, I take the 4 and I multiply it by negative 1 and ask myself, what are the factors of -4 whose sum is -3? And we know that -4 and +1, their product is -4 and their sum is -3. So I can go ahead and put this in 4 terms and apply the grouping method. Next thing is you group your first 2 terms, apply the GCF from each group. Again, the GCF of this group right here is 1. Again, we have a common binomial factor of x minus 1, so we can distribute the x minus 1 out, and whatever is left over will be 4x plus 1. Apply the zero product property, so take each factor, set them to equal 0, and solve for x. Then we go and check the solutions mentally. So first by letting x become -1, see if the left side does equal the right side. Then let x become -4, see if the left side does equal the right side. And if they are same on both sides, that will be the solution to your quadratic equation, your radical equation. So the solution to this problem will be x equals 1 and x equals -4. Well, that was part 1, and I'll put together another video, part 2. Again, thank you so much for taking your time working the problems out. I am certain you guys did a very good job working it out. Give yourselves a high five if you got the right answer, and we'll do some more problems on the next video. Thanks, guys.